In a 480 volts lift station scenario where one service comes from the power company to the meter can and then to a double throw switch, and a second service comes from a standby generator to an automatic transfer switch, or ATS, and then to the same double throw switch, it is crucial to understand the proper wiring methods to maintain safety and code compliance. You cannot run the conductors from the power company to the ATS in the same conduit as the conductors coming from the ATS to the control panel. The fundamental reason for this separation lies in the function of the ATS as a safety device. An ATS is specifically designed to isolate the power company's service from the standby generator service. This isolation is essential to prevent backfeed, short circuits, and other potentially hazardous conditions. When conductors from the power company and the standby generator are run in the same conduit, there is an inherent risk of the two services coming into contact with each other. This contact could be due to insulation failure, physical damage to the conductors, or other unforeseen circumstances. If such contact occurs, it can create a direct short circuit between the two power sources, leading to a fire, equipment damage, or even personal injury. Electrical codes and best practices mandate the physical separation of these power sources to mitigate these risks. Instead of running the conductors in the same conduit, the conductors from the power company and the standby generator must be run in separate conduits. This physical separation ensures that a fault in one system will not directly affect the other system, providing an additional layer of safety and protection. To further enhance safety and clarity, each conduit should be clearly labeled to identify the power source it serves. The conduit containing the conductors from the power company service should be labeled Power Company Service, while the conduit containing the conductors from the standby generator service should be labeled Standby Generator Service. These labels should be durable and easily visible to anyone working on the electrical system. The two conduits should be kept physically separate from each other at all times. This means that they should not be bundled together, run parallel and in close proximity, or otherwise allowed to come into contact with each other. The separation should be maintained throughout the entire length of the conduit run from the point of origin to the point of termination. In addition to the physical separation of conductors, it is also important to ensure that the grounding systems for the power company service and the standby generator service are properly isolated. Grounding systems are designed to provide a low impedance path for fault currents to return to the source, tripping circuit breakers or fuses and de-energizing the circuit. If the grounding systems for the two services are interconnected, a fault in one system could create a ground loop, which can lead to circulating currents and other undesirable effects. To avoid this, the grounding systems should be kept separate and isolated from each other. This can be achieved by using separate grounding electrodes for each service and ensuring that there is no direct connection between the grounding conductors. Another important consideration is the overcurrent protection for each service. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can be caused by short circuits, overloads, or other faults. Each service should have its own dedicated overcurrent protection devices that are sized appropriately for the conductors and equipment being protected. The overcurrent protection devices should be located as close as possible to the source of power to provide maximum protection. It is also important to ensure that the wiring methods used for each service comply with all applicable electrical codes and standards. These codes and standards provide detailed requirements for the installation of electrical wiring, including conductor sizes, conduit types, and grounding methods. Compliance with these codes and standards is essential to ensure the safety and reliability of the electrical system. In summary, the separation of conductors from different power sources is a fundamental safety principle in electrical installations. By running the conductors from the power company and the standby generator in separate conduits, labeling the conduits clearly, and isolating the grounding systems, you can significantly reduce the risk of electrical hazards and ensure the safe and reliable operation of the lift station. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installation complies with all applicable codes and standards. Proper electrical design and installation are critical for the safety of personnel and the protection of equipment. The requirements outlined are generally in accordance with the National Electrical Code, also known as NEC. It is necessary to refer to the latest edition of the NEC and any local amendments for specific requirements in your jurisdiction. These codes provide detailed information on conductor sizing, conduit fill, overcurrent protection, grounding, and other aspects of electrical installations. The specific sections of the NEC that are relevant to this topic include Article 225, Outside Branch Circuits and Feeders, Article 230, Services, Article 445, Generators, and Article 700, Emergency Systems. These articles provide detailed requirements for the installation of conductors, overcurrent protection, grounding, and other equipment used in these types of installations. For example, NEC Section 225.30 generally requires that outside feeders and branch circuits shall be installed in accordance with the requirements of Chapter 3. Chapter 3 covers wiring methods and materials. NEC Section 230.7 generally requires that service entrance conductors be insulated. Section 445.12 generally requires that generators be protected against overloads. Article 700 covers emergency systems, which are typically backed up by a generator and have very specific requirements. It's crucial to consult these sections of the NEC for detailed guidance on how to comply with the code. Also, remember to check for any local amendments to the NEC that may be in effect in your jurisdiction. Local amendments can add to or modify the requirements of the NEC, so it's important to be aware of them. In addition to the NEC, there may also be other applicable standards such as those published by the Institute of Electrical and Electronics Engineers, known as IEE, or the National Fire Protection Association, known as NFPA. These standards provide guidance on specific aspects of electrical design and installation and may be referenced by the NEC or local codes. Always consult with a qualified electrical professional to ensure that your electrical installation complies with all applicable codes and standards. They can help you determine the specific requirements for your installation and ensure that it is installed safely and correctly. The importance of proper labeling cannot be overstated. Clear and durable labeling is essential for the safety of anyone who may work on the electrical system in the future. Labels should be permanently affixed to the conduits and should clearly identify the power source they serve. The label should be made of a material that is resistant to weathering, fading, and abrasion. The labels should also be placed in a location where they are easily visible and accessible. In addition to labeling the conduits, it is also a good practice to label the circuit breakers and other equipment associated with each power source. This will help to ensure that anyone working on the electrical system can easily identify the source of power and avoid accidental contact with energized circuits. The grounding system is a critical component of any electrical system. The grounding system provides a low impedance path for fault currents to return to the source, tripping circuit breakers or fuses and energizing the circuit. A properly designed and installed grounding system is essential for the safety of personnel and the protection of equipment. The grounding system should be designed to meet the requirements of the NEC and any other applicable codes and standards. The grounding system should also be inspected and tested regularly to ensure that it is functioning properly. The overcurrent protection devices are another critical component of any electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can be caused by short circuits, overloads, or other faults. Each circuit should have its own dedicated overcurrent protection device that is sized appropriately for the conductors and equipment being protected. The overcurrent protection devices should be located as close as possible to the source of power to provide maximum protection. The overcurrent protection devices should also be inspected and tested regularly to ensure that they are functioning properly. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrical professional before undertaking any electrical project. A qualified electrical professional has the knowledge and experience to ensure that the work is done safely and correctly. They can also help you to comply with all applicable codes and standards. Improperly installed electrical wiring can create a fire hazard, shock hazard, or other safety hazard. It is always best to err on the side of caution and consult with a qualified electrical professional before undertaking any electrical project. The automatic transfer switch, or AT, plays a crucial role in ensuring a seamless transition between the utility power and the standby generator. It constantly monitors the utility power and, in the event of a power outage, automatically switches the load to the generator. This ensures that critical equipment and systems continue to operate without interruption. The ATS should be installed and maintained according to the manufacturer's instructions and all applicable codes and standards. The ATS should also be tested regularly to ensure that it is functioning properly. The specific requirements for the installation and maintenance of an ATS will vary depending on the type of ATS and the application. Always consult with a qualified electrical professional to ensure that the ATS is installed and maintained properly. When dealing with electrical systems, it is also good to have some protective gear such as safety glasses, insulated tools, and voltage testers. Firstly, safety glasses can help protect your eyes from flying debris or accidental contact with electrical components. Secondly, insulated tools can help prevent electrical shock if you accidentally come into contact with an energized circuit. Thirdly, voltage testers can help you verify that a circuit is de-energized before you start working on it. These simple precautions can help to reduce the risk of electrical injury. Working with electricity can be dangerous, but by following safety precautions and consulting with qualified professionals, you can minimize the risk and ensure a safe and reliable electrical system. Furthermore, maintaining accurate documentation of the electrical system is also important. This documentation should include wiring diagrams, equipment specifications, and maintenance records. Accurate documentation can help you to troubleshoot problems, perform maintenance, and make modifications to the electrical system safely and efficiently. The documentation should be kept in a safe and accessible location, and it should be updated regularly to reflect any changes to the electrical system. Finally, electrical safety training is essential for anyone who works with or around electrical equipment. Electrical safety training can help you to understand the hazards of electricity and how to work safely around it. Electrical safety training can also help you to comply with all applicable codes and standards. There are many different types of electrical safety training available, so it's important to choose a training program that is appropriate for your level of experience and the type of electrical work you will be performing. In addition to formal training, it's also important to stay up to date on the latest electrical safety information. You can do this by reading industry publications, attending seminars, and consulting with qualified electrical professionals. By staying informed and following safety precautions, you can help to reduce the risk of electrical injury.